So let's take the basic circle. Already we know some circular motion. No? So in that, what are the basic things what we made observation? This is the radius vector and there's a tangential velocity. And what is angular velocity? Angular velocity was directed like this. Any condition for that V, R and omega. And we had some vector relationship like this. Can you remember? V bar equal to omega cross R bar. V bar equal to omega cross R bar, that one. Any relation between V and R? Perpendicular. This is something very important. What is the angular velocity? So here, what was the center? The center O was at rest, no? This was a particle P. What is the state of O? O is at rest. We discussed all the problems where O is at rest here. So now we are going to take a problems where the reference point is going to be in motion. Then what has to be done? Is it okay? Simple relative angles, relative velocity we studied in kinematics. Now it's a relative angular velocity. Got the idea? This will be. So now, what is the, again, I'll stick on to the basic definition. So this is one very important thing which I'm going to conclude here. Okay, these are the points A and B. Let the velocity of particle A be this one, and let this, and this is a L. This is a length L. Then how to get the angular velocity of the particle A with respect to particle B. So what is the basic definition? Then the basic definition will go like this, no? Then velocity of A. So here what you write? Velocity of P with respect to O, and O was a test. So here velocity of A with respect to that should be equal to L AB into omega AB. V equal to R omega. How we write? Velocity of particle P with respect to O is equal to position of particle P with respect to O, angular velocity of P with respect to O. The interpretation is like this. Since the O was a test, we didn't bother. Velocity of P with respect to O, position of particle P with respect to O, then angular velocity of P with respect to O. So that was the interpretation of that. Since O was the test, we didn't bother. Okay, now the O is also motion, so that I'm taking one separate situation here. It will be like this. So now we know what is VAB, LAB. I'm taking this as reference. LAB. So if I take this as reference, then what you are going to write? LA minus LB into angular velocity of A with, and this we know from the both are same direction, VA minus VB are right. So VA minus VB. So LAB I should measure in this direction. No? So LAB in what direction you're going to measure? In this direction. And what is LAB is equal to? Is equal to L. So here I'll get. What about the direction? The direction is given by the vector form. I'll write it in vector form. Omega AB bar is equal to VA bar minus VB bar by L. So what is the direction of it? VA bar minus VB bar. So angular velocity of A with respect to B, what is the direction of it? So the direction of it will be, it'll be like this. Agreed, all of you? So now, next I want omega BA. So omega BA. So what is the basic formula will be now? The same diagram. And this is very important. Once you get this, rest of everything you can manage. Everything based on again the formula, and you can easily manage. First, the basic idea, clarity is needed. So I'll measure now this one. So here VBA is equal to, you're going to write LBA omega BA. So VB bar minus VA bar. let me write in vector here only. LBA. LBA, how you measure? Opposite to LAB bar. Opposite to LA bar. So LAB bar we measured upward. So okay, this one. So it should be like this. So LBA bar I should measure like this. So shall I write minus L compared to the other diagram? So omega BA bar so this if you rewrite, you're going to get it as okay, what is the direction of angular velocity of B with respect to A? It is also in same sense. So how I to show? Same sense means how it should be. It was a clockwise, no? Here also it should be clockwise. So here the omega BA should come like this. Sense is same. You see that sense is same clockwise. So it's also clockwise. So both will be in same sense. Got the idea? So sense should not be different here. So the angular velocity of A with respect to B and angular velocity of B with respect to A, both are equal and both will be directed in same direction. So shall we conclude? Wait, I'll conclude here. So omega AB therefore. So what is the conclusion now? Omega AB bar is equal to omega BA bar. It doesn't matter. It's telling.
Sir, instead of sense of rotation thing, could you just tell me which direction omega will be there?
Omega will be out of the plane. So here into the plane, here into the plane. There's the only sense of rotation I'm telling. So omega will be, directly you go for it. Curl fingers in the direction of that arrow. Then the thumb will point into the plane. So omega will be into the plane in both the cases. So the direction is same, no?
Sir, I still didn't get it. So could you just show?
Here actually, if you take this x-axis, no? Y-axis, so it will be omega AB bar, BA bar will be in the direction of minus k cap. Z-axis will be out of the plane, no?
Yes, sir. Could you just tell me how? I'm not getting it.
Curl, right hand screw rule, no? Here I got the thing now. You look at the the curl fingers, right hand screw rule, vector cross product, similar to that, curl fingers. So just close fingers, no? I'll curl fingers like this. Then the thumb will point into the plane, no?
Yes, sir. Understood, sir.
Okay. This is very important. So once you know this, rest all mathematics you can see very easy. You can feel very convenient now. Can you hear me? Can you hear me?
Yes, sir.
Okay, I'll continue now. Yeah. So this is about the okay. This is about the basic thing, that one. Okay. Now I'll go for like two particles if they are revolving in a circular path. We'll discuss between the particles now. There's a particle